Hello all, welcome to the subject of VLSI Design and Technology. This is Professor Meenakshi Pantha from Electronics and Telecommunication Department, Parvatibai, Canberra, Modi College of Engineering. In the previous lecture, we have seen the different types of the structures and descriptions of the VHDL. So today we will see the detail about the data flow description and many of the program how to write in HDL language using the data flow description we will see. The data flow description, it is a one type of the hardware description language, and other type include we have seen already in previous lecture like a behavioral structural and behavioral structure mainly based on gate level and switch level mixed type and mixed language. Many of so listed some of the fact of this data flow description is that data flow description simulates the system by showing how the signal flow from system input to output. For example, the Boolean function of the output or the logical structure of the system shows, such as shown here in the flow. I will explain. The signal assignment statement are concurrent in this data flow description, and at any simulation time, all signals assignment statement that have an event are executed concurrently. Here, all the simulation at any simulation time, the assignment statement they have operate all the events and executed concurrently. The entity name in the system, and there are two input and output we have seen in last previous exam while we are discussing about half adder or some we have seen a small example by using data flow description. So today we will see with a small example exactly what is the architecture, how we can write the architecture of this data flow. The architecture of data flow, there are two inputs and two output. We are considering one of the small example, and the statement are also there, one and two statement, and to assign a value to the output, and the signal assignment operator is, I will explain with an example here. See, let's see with a small example exactly how the data flow description will be takes place. So entity, first start with the entity. The name of example is a system keys, and now going to assigning port I1, I2, in bit 01, 02, out bit. Today we are going to see how the data flow architecture or how the data flow description after assigning the port, the entity should be and with the predefined word and. Then begin the architecture. Here architecture, we should give the name of architecture. I am giving here df of system. For what entity we are going to construct the architecture? The entity name is system, which is having two input and two output. Two input and two output port is there. For that purpose, for that entity, we are going to construct the architecture by using a data flow description. Data flow description method. So we have to begin with the predefined word statement begin. Now we have to assign the output. So this is output. How we are going to assign output here? Using this assignment operator. Using this assignment operator, we are going to assign the output, how behave with the input. So these are the input. The AND operation should be performed here. And these are the statements. Statement 1. And second output should perform. I am going to assigning XOR operation here. Statement 2. Here both the statement 1 and statement 2 both are what statement they are? Signal assignment statement. And we have to end the architecture with predefined word and with the name of architecture D underscore F. This is our name of the architecture. So first we have to assign the entity and declare the ports, what type of ports, how many input and how many output. After the entity should be end with a predefined word and then after assigning the entity, architecture should be constructed by using, in this example, we are going to construct the architecture by using data flow description. So we have to mention there by using predefined word architecture and we should give one name. I have given here capital D underscore F of the system. Here system is the name of the entity. I am given the name of entity system. This is the user defined system. Here name can be user defined. Whatever the name user can give, this will not affect to the system. So after that we have to begin to construct the architecture using data flow by using a predefined word begin. First we have to start with the begin command. After writing begin command, we have to assign the operators, how the output operator will perform with the performance of the input signals. See here, the output 0, 1 is assigned. The value or result, whatever it may be there, it will be going to assign or add the output port by performance of input ports. Here, I1 and I2 are these input ports. So, what operation will be performing here? I1 and I2. The AND operation will be takes place by using these two terminals. And the another output is 0, 2, which should be, what is that? Output is 0, 2, which will obtain the result XOR operation of these two terminals, I1 and I2. At these two terminals, whatever the signals on these two terminals which performs the XOR operation and result will be obtained at 0 to terminal. This is the architecture. How the inputs are operating. They're simply assigning here. So here we can say that the HDL code for describing the system, here the example name is a system. Here we have mentioned in the entity using data flow description. The entity name is a system here, and there are a two input terminal I1 and I2 and two output terminal, that is 01 and 02. The statement 1 and statement 2 are used to assign the value of the output. These two statements are used for value assigning the output, and the signal assignment operator. This signal operator is used in a VHDL or predefined word assign. We can use instead assign, we can also use in assign will be used in a very long. Here in this VHDL, this sign will be going to use. This is the one small example of data flow description. Let's see how the operation will be undergoes inside the architecture. By listing this figure, let's see how the let's see the operations of and OR gate, how the signal will be going to assign. Here signal A, B, C and D are the inputs and signal Y is the output. Here in the circuit, this AND or simple AND or operation, here see the A, B, C, D all are the input and Y is the output. And the signal S1 and S2 are intermediates. Here the output of this AND gate, that is S1, and output of this AND gate is S2. And these two signals are known as intermediate signals. The input and output signals are declared in the entity. In the entity, what we are going to declare? The input and output we are going to declare. In the signal has to be declared before it can be used. In the input and output signals are declared in the entity. How we are going to declare? As a port. As a port, we are going to assigning here input and output. In the HDL, the signal has to be declared before it can be used. Accordingly, the signal S1 and S2 have to be declared. So in VHDL, these S1 and S2 are declared signals by using predefined word signal. It is in the architecture. See here, while we are writing in the entity declaration, only input and output we are going to assigning. Here the input terminals are A, B, C, D and output are Y. These things are we are assigning as a port in the entity part. But what about these two signals? So these two signals, which can be using as a predefined word, we are going to assign as a predefined word signal in the architecture. These two signals we should assign in the architecture as a predefined word signal. So how? See, in the architecture part, the S1 and S2 should be assigned as a predefined word signal. This is S1, S2. These two are bit type of data. We have to assign like that. A signal assignment statement is used to assign a value to a signal. The left-hand side of the statement should be declared as a signal, and right-hand side can be a signal A and as a signal as a variable or a constant. The operators for the signal assignment is this assignment we should be used. What type of assignment? This assignment operator should be used in the VHDL, or the predefined word. The execution of the signal assignment statement is unique and different in the concept from the software language C. The execution is done in a two-phase. One is calculation and assignment. The execution time T0 of the signal assignment statement is like that. We have to assign the 0, 1. This is the assignment operator we have to assign, and what we have assigned in the previous example like this, we have assigned, and right now we have assigned. So assume that there is an event are going to take place at the value of t. As he said that the assignment execution operation can be done in two phases. One is the calculation phase and second one is assignment phase. So first see the calculation phase. What is the calculation phase? The value of 0, 1 is calculated by using current value of I1 and I2 at the time of 0. See here. At time 0, we are considering time is also here. So at the time 0, the 0, 1 value will be calculated at the current value of I1 and I2 at the time T0. And this value is, for example, I am thinking these two values are 1, 1. These two values are 1, 1. So we will get the output 1. In the, and where and are logical and operator in the VHDL. So the value still not assigned at 0, 1. So assignment phase, what will happen in the assignment phase? The calculated value assigned to 0, 1 after a delay time. The delay time can be implicitly or explicitly specified. For example, explicitly specifies 10 nanosecond delay time is also there. After 10 nanosecond, the values, calculated values are going to assign at the 0, 1. So if there is no delay time is specified, the HDL use a defined infinitely small delay time which is called as a delta second at T0 plus delta. Assign at T0 plus delta. Delta sign is there, so I am writing name instead sign. See there, here in the architecture part, there are two phases are going to undergoes. First stage is called as a calculation stage. Calculation. In this stage, what will happen in this calculation stage? The present value, whatever the value present at I1 and I2 is performed an AND operation, and at the time T0. At the time T0, these two value perform whatever the value present in these two terminals, they will perform the AND operation. But still at the time 0, they are not going to assign it 0, 1. They are going to assign the value in assignment phase. Here, assignment phase. In this assignment phase, what will happen? Whatever the value calculated, for example, 1 is there, this 1 is not directly assigned here at this time. This will going to assign into 0, 1 at the, this value will be assigned 0, 1 at the time of T0 plus delta. Normally, if this delta value is not mentioned, it may be a 10 nanosecond. If it is not mentioned, it will take a small amount of time for assigning into 0, 1. That time is, we can say that delta time. So at this T0 at this time plus delta time, the value 1 is assigned. The value of 1 is assigned to this 0, 1. The HDL data flow description, concurrent signal assignment statement constitute a major part of the body of VHDL architecture. The VHDL architecture is a concurrent statement. The another type of execution is a sequential, but where the statement are processed sequentially. For the execution of any concurrent statement to start, an event on the right hand side of the statement has to occur. An event is a change in the value of signal or a variable, such as change from 0 to 1 or low to high or high to 0. That is means high to low. The statement remains inactive if no event occur. If an event occur, one or more than statement, then all these statements, regardless of their order or location in the architecture, are executed concurrently. This is a simultaneously. We all are know how the data flow description program should be written of this half, using this half adder system. For this half adder system, how the data flow description description program we have written, we have already seen in the previous lecture while we are discussing this data flow description. But we have to see how the time delay should be added to this small example. First, see, this is the half adder which is having a two input bits and output bits. The result is as a two output bits, one bit of sum and another bit is called as a carry out. One bit is a sum and another bit is carry out. For example, half adder, the addition of 1 0. For example, for the half adder, for the addition of half adder, here the 1 and 0, the 1 and 0 is nothing but output is the output is 1. Here. For some operation, the output is 1. For 1 plus 0, what will get? Output is sum. For adding these two bits, sum will get 1. And what about carry? There is no carry, hence this is 0. No carry, so 0. We see here in the table. If the A and B both are 0, 0, the sum is 0 and carry also 0. If the input A is high and output B is, sorry, another input B is low, then output sum is high and carry remains 0. Carry when will be high? When both the input are high. When both the input are high, then only the carry will become high. To describe the half adder using data flow description, we write the Boolean function of the output. We should write the Boolean function for this output. The function shows how the data flow from input to output of the half adder. So that function, that Boolean output function will show how the input, how the data will be flow into the input, from the input to output. So the table shows, this table shows the truth table of half adder, and this figure shows the logic diagram. This is the logic diagram of the half adder. We can obtain the Boolean function from the truth table. The Boolean function of output we generated by using min term. So where the output have sum 1 and max term, or max term where the output of sum of 0. The Boolean function using mean term in the sum of product of SOP form is. How we can analyze the Boolean function, how we can write the Boolean function. Sum is equal to, according to truth table, when A is 0, that means A bar and so at this operation the sum will be get a output. So this operation will be act as A XOR B. A XOR B. So the output become high when this function will be, we can calculate it by using this truth table. The sum will be perform, what operation is going to perform here? XOR operation. And what are the carry, when we are going to get carry when A and B both are high. So at that time we are going to getting a carry. So we have to, when both are high only, then we are going to get high. So the AND gate will provide only high signal when both the signals are high. So this is the logical function. So to this function, how we can add delay, you can also see. First, we have to construct an program, HDL program for this half adder function. entity half adder is and port. After entity, we should assign a port. Here A is bit type and B is another input. We have to mention here in. This is the input and this is also in, which is also bit type. And sum, that is out bit, and carry, that is also out bit. This is port assignment for the half adder, and we have to end with the predefined word and half adder. After architecture should be right half adder of, for what entity? Architecture name should be different from the entity name. So we are going to write the data flow. I will give data flow df of adder is begin. How to begin with the begin statement. Then we have to assign the operator, output operator. Sum will be obtained when performing or after performing XOR operation of bit A and B. And C will be going to A and B. And F. We have to end with the architecture and with the name of the architecture. So this is the small example of the half adder. So now we have what we do have. We have to assign a time delay to these signals. So what we have to do? See here in the previous lecture we have seen that there is a internal signal is also there. So that signals we have to write delay function. So to assign a delay time to a signal assignment statement, we have to use predefined word after in the VHDL. What we have to use? We have to use predefined word after, and time delay should be mentioned with the hash. So see here. How we have to assign? If I want to assign the time delay for this we can write A XOR B after 10 nanosecond. 10 nanosecond. So like this, we have to give a time delay. So this is the statement we can use for assigning. Here we can assign after 10 nanosecond. Like this, we can assign the time delay. it will calculate, but it will assign in a in calculation phase it will calculate. In assignment phase will take it will take few seconds, that is 10 nanosecond plus this time at this at for example at time t0 the calculation will be done, and it will going to assign as t0 plus 10 time. After this much of time the value result will be going to assign into yes. So this is the way of assigning time delay. So let's see how the program have to be write to mux operation here. Here this is the 2-in-1 multiplexer with the active low signal. This signal is a active low signal here. Here, this signal is active. If bubble is here, then this signal is nothing but active low signal. Or instead bubble, you can also like this. Like this. This is the basic 2-in-1 multiplexer, which is having one input and one bit select line, which is having the 2-in-1 multiplexer with an active low, which is having basic 2-in-1 multiplexer, two 1-bit inputs and one select line is also there, and 1-bit output terminal is also there. Additional control signal may be added, such as a enable. Another one signal will be added, which is called as a enable, and the output of basic multiplexer depend upon the level of selector line. How the output will be depend and what output will be depend, that will be based on the select line. If the select